Hey guys, welcome to another dynamics video. Today we're going to be solving a question which asks us, what is the minimum amount of force needed to make M2 slide over M1, where M2 is this top 2 kilogram block and M1 is this bottom 1 kilogram block. And in case you don't understand my diagram, there is a static coefficient of friction of 0.2 between the top and the bottom block, and the floor is frictionless. And you're going to be applying force onto the top block. Okay, so with all that said, you should go ahead and solve this question for yourself, and then come back when you've finished. Alright, so in order to really understand what's going on here and how we should approach this question, we should draw a free body diagram. So, let's start by drawing the forces that are acting on this top block, M2. So, we know it is going to be the force that we are pushing the block with. I'll just call it the force of our hand. And we know that it's going to be the force of friction leftwards, or opposite of our motion. And why is this force of friction to the left? Well, we're going to be pushing this block to the right. And friction is always trying to oppose the direction of attempted motion. So it's going to be going opposite of the direction that we push. And for this bottom block, M1, there's only going to be one force. That's going to be the force of friction, of static friction. That's why I read friction. And why is this force of friction going to the right when this force of friction is going to the left? Well, first of all, Newton's third law tells us that by definition, every action has an equal and opposite reaction, so these two forces must be in opposite directions. And if you think it's weird that there's going to be friction pushing this block to the right when there's no force doing anything else, I encourage you to take a piece of paper and then put any object on it and then push the top object, and you'll see that the bottom object goes in the same direction that you're pushing it. And that's because there's friction from the top object to the piece of paper, and the piece of paper in this case is the bottom object. And I guess that's how you can prove to yourself that this is true and that there is friction that's going to be pushing the bottom block, or in this case the piece of paper. Okay, great. So first, let's write the two equations that we get from these two free body diagrams, and then let's try to address the question. So the first equation would be the force of the hand minus the force of friction, and that's just again for static friction, because that's what it's going to be, is equal to ma. In this case it's this mass and this acceleration. And the second equation is just static friction on the bottom block is equal to m1a1. Okay, so let's think about what this question is asking us. So it's saying, what's the minimum force we need to have so that this top block slides along the bottom block? And how can something slide across something else? Well, that means it has to be going faster than the bottom thing, right? That's how it's going to slide across of it. Which means that it must have a bigger acceleration than the bottom block. So we can say, for what force of our hand is the acceleration of the top block going to be greater than the acceleration of the bottom block? When is this true? What's the minimum amount of force that we need to apply so that this is true? So, first let's plug in numbers for all of our variables and then address the question. So this is still what we're trying to solve for. So there's no numbers for this. And then the static friction force is going to be normal force, which is 2 times 10. And I'm using 10 for gravity because I want to, times 0.2. And that's going to be equal to m2, which is 2, and then a2. Okay, now you might be wondering, this static friction force is the maximum the static friction force can be. So why am I using why am I using the max static friction force for the static friction? Well, I know that right before this top block slips on the bottom block, it's going to be not slipping, right? And the static friction here is going to be opposing my motion, the amount that I'm pushing, which is much force that it can, because it really wants this top block to not slip. So, right before it slips, there's going to be the maximum static friction force exerted. And using this, I'm going to find the minimum force of my hand. Because I'm trying to find the minimum force I need to use to slightly overcome that maximum static friction force. And because these two forces have the same magnitude, I'm going to use the same numbers for static friction in this equations. And then M1 is just 1, so it becomes A1. And this, I want to plug these two equations into this inequality, so I'm going to isolate for A2. So, we're going to have F hand minus 2 times 10 times 0.2, all of that divided by 2 equals A2. Okay, well, now that we have A1 and A2, let's do what I want to do and plug these guys in. So, we have that A2, which is F hand minus 2 times 10 times 0.2 over 2 equals 2 times 10 times 0.2. Okay, well, now we can solve for the force of the hand, and you can solve this and you'll get 12 newtons. And that's the answer. If you push with 12 newtons of force, this top block is going to slide across this bottom block. I hope you enjoyed the video, and thank you for watching.